Hello everyone, today we are going to go through beautiful triplet, which is a poem under implementation section of algorithm on HackerRank. So without wasting time, let us have a look on the poem statement. So in this poem statement, we have an array as input, and then we are supposed to find out if we can find a triplet in that array that respects this condition: A of I, A of G, A of K, in such a way that I is less than G, which is less than K, and A of G minus A of I is equal to A of K minus A of G, which is equal to G. So the first thing we need to take into consideration is that the array is actually an increased sequence, so the array is automatically sorted. So we don't need to worry about that. And then the next thing we need to do is that we need to find out how many elements are actually respecting this condition. Let us take some example and see how it look like. We have this array, for instance. We have an array of 2, 2, 3, 4, and 1. And then we want to find out the number of couple. So what we can do is, when we can see that, one example is that we can see this element 2, the element position 0, plus 1 gives you 3, which is in the array. 3 plus 1 gives you 4, which is also in the array. So 2, 3, and 4 is actually a couple. And you do agree with me that this also 2, 3, and 4 is also a couple. So those are really two solutions. 3, 4, and 5 is also a solution because 3 plus 1 is equal to 4, 4 plus 1 equal to 5. So those are the three solutions of this array. Now that we went through an example, how can we approach this solution? So before diving into the solution, if you're not subscribed to the channel, I really encourage you to subscribe because this is what we are doing here in terms of data structure and algorithm and problem solving. So one brute force approach of solving this would be to have a tree nested for loop that will lead to complexity of big n of n power of 3, which is something you don't want because you may face some cases because of the possible value of n. So in this problem, what we are going to do will be find the best solution, like a nice solution, big of n solution. And then how are we going to think about that solution? How are we going to organize ourselves to achieve that? So we are going to see the problem in the sense of an element is actually a possible solution. An given element is actually a possible solution if the element minus d exists and if the element minus d also exists, right? That means if you have, for instance, 5 is a possible solution because 5 minus 1 will give 4 and 5 minus 2 will give 3, which are in the array. Okay, so let us take an example of approaching this with the solution I just mentioned. So we can take this one as array, and then we are going to have our d here. So we are going to say, okay, for this one, at the beginning, we are going to construct a map to know which element exists, to kind of reduce the load of searching an element, because you are going to search element. If you want to check if 5 minus 1 exists, you are going to check if 4 exists in the array. So to kind of reduce the load of searching, we are going to make use of a map. So we are going to create a map. The map will be actually empty. At the beginning, the map will be empty. You are going to start, okay, so this is the element where we are starting. Does 2 minus 1 exist in our map? 2 minus 1 doesn't exist because the map is actually empty. Does 2 minus 1 minus 1 exist in our map? No, it doesn't exist because the map is empty. So this one cannot be considered as a possible solution. Now we move to this one, the same thing. It doesn't exist. While moving, every time you find an element, you just add the element to the map. So at this point, we already have 2 and 2 in our map. So we move forward. So we are going to this one. Does 3 minus 1 exist in our map? Yes, it does exist. It does exist. Does 3 minus 1 exist in the map? No, it doesn't exist. So this one cannot be a solution, right? We move to this one. Does 4 minus 1 exist in the map? Yes, this is 3. It does exist in the map, and then it exists one time. So the value of map of 3 will give 1. Does 4 minus 1 exist in the map? Yes, this is 2. And then this one will give 2 because it appeared twice in our map. So this one, to have the number of solutions that we can have with last element 4, it will be 1 times 2. And then you can see that those are those solutions, this one and this one. So we have the 0, 2, 3, the 1, 2, 3. Those are the solution with the ending of 4. Ending of 4 is a position 3. So don't misunderstand this. So with 3, does 5 minus 1 exist in the map? Yes, it does exist. That is 4, and it exists 1. So 5 minus 1 will give 1. And does 5 minus 1 exist in the map? Yes, 3. It exists, and it exists 1. So this will give 1 times 1, which is 1 valid occurrence with ending 5, which is this solution. So you do agree with me that with this approach, we are able to have our solution in big O of 10. So how will the implementation look like? So the first thing we are going to do to create our map, like I just said, we are going to create our map. And then with the map, we are going to initiate our result at 0, the result that will count the number of elements, and then we return the result. Now we are going to perform our loop. We are going to loop through the element of the array. And then for each of the element that we see, we kind of increase its occurrence in our map. And then we are lucky that when an element doesn't exist in the map, it returns 0. So that is why if just one element exists and the other doesn't, you times the element times 0, and they will return 0, which is something we want. So we are going to say result plus equal to the number of occurrence of the element minus g, and the number of occurrence of the element minus g, or minus 2 times g. So by doing so, we are sure that, okay, at the end of this, we are going to have our solution with a less, with a complexity of big O of n. So let us run and see what it is. Nice, everything is going. So this is my approach of solving this. I hope you do enjoy it. Feel free to leave me a message in the comment section if you want us to interact about this. See you on the next video. Ciao. Take care. Keep learning.